Great. Well, that's about. I'll give this one. I don't know. No. Yeah, but it's. That's like. That's not really. That's
Hey, page 9.
I was, but was it whole, maybe I should have so seriously. It's just like, yes. No, I did.
How old were you once?
Page 9.
So,
So yesterday we started a little bit on trig derivatives. And today we're just going to be working on building off of these derivative rules. Okay, guys. So there, we derived the other rules such as tangent, cotangent, secant, cosecant using product and chain rule, but we don't want to have to do that every time when we're recalling these rules to apply to finding derivatives. So this is the way that I organize the derivative rules. So I encourage, you can use this pattern or not, but just want to kind of show this to you. This is at the bottom of, for example 2. Example 2 won't take a whole lot of space. So I want to show how I kind of organize these 6 derivative rules. So we're going to do 2 columns here. So we'll do derivative of sine of u. Also, we're going to start converting them into chain rule, so that we can always look for that u value, and there's always that u prime involved. So we have the derivative of sine, derivative of tangent, and the derivative of secant. And then give some space. And then derivative of cosine. And then derivative of cotangent. And then derivative of cosecant. So sine and cosine, their derivatives are just basically each other. Sine's derivative is cosine of u times u prime. Cosine's derivative is negative sine of u times u prime. Tangents and secants, their derivatives basically just involve each other. So tangent's derivative is secant squared u times u prime. Much the same way, cotangent is going to follow a similar pattern as tangent. It's just going to use the function below it. Cotangent derivative is negative cosecant squared u times u prime. And the secant's derivative involves itself and the one above it. So secant's derivative is secant u tangent u times u prime. Cosecant derivative involves itself and the function above it, negative cosecant u cotangent u times u prime. So the thing I like about this layout is there's a lot of nice patterns. First, you are going to organize all your trig functions that start with C in alphabetical order, at least alphabetical order for these abbreviations. So COS, COT, CSC. And all the C functions produce negative derivatives. So that's a nice pattern to see. Sine and cosine, they both have a similar pattern in the sense that they involve each other. Tangent and cotangent, they both have a similar pattern in the sense that they're both a trig function squared. And secant and cosecant, they both have a similar pattern in that they both involve the function and the function above it. And we talked about how tangent and secant have the fact that they just involve each other. And cotangent and cosecant is just going to follow whatever pattern they see with tangent and secant. And so my suggestion is, we'll practice this every day, and hopefully, after a few days, you'll feel comfortable creating your 6 derivative rules. I like for you to be able to write this down at the top of your quiz when you take your quiz. And also, I really want to suggest that we do this on the AP exam as well, because it looks like it's only 6 rules, but it's actually 12 rules, because next semester, when we do antiderivatives, we're just going to be working backwards. So the derivative of sine is cosine, but the antiderivative of cosine is sine. So having these 6 rules at the top of your AP exam, you can always reference it. But I think, on this year's AP exam is going to be hybrid. So most everything is going to be on your device for the problems, but you can always write down these rules on your scratch sheet, and then you can work your way through. So these only look like 6 rules, but by next semester, it's going to actually turn into 12 rules since we're working backwards. Okay, so let's try example 2 here using the rules that we just created. Sine of 5x. So we see that sine of 5x matches that sine of u rule. So following the rule, what do you think sine of 5x's derivative would be? Cosine of 5x times 5. Yeah. So I like to memorize these rules with that u prime, because then we're always understanding that that we're always looking for that chain rule portion, right? Even if it's not there, even if it's just sine of x, it's not hurting us. We're just doing times 1, but it's nice to just always be looking for that chain rule portion. So I like to memorize rules with that u prime. Right. And then this 5 is not the same as this 5x, right? This is a coefficient, but the 5x is inside the cosine function. So we like to put the coefficient in front. So even though these are trig functions, the derivatives still serve the same purpose as before. It's just describing the slope behavior of the original graph. All right, next page. Y equals square root of cosine of x squared. We want to spend the time to rewrite it using rational exponents. Oh, and then one thing, make sure that we can't cancel these out. Okay, that squared is not impacting the entire trig function. It is just impacting the portion inside the cosine. So we can't just cancel that out and just call it cosine of x. Okay, so Let's rewrite it using a set of parentheses or brackets. So we have outside portion and inside portion. We know we have to go through what rule here? Chain rule, right? Yeah. Right, so we start off with outside's derivative. Bracket to the 1/2. We do power rule there. Keep the inside portion intact. And cosine x squared becomes what? Negative sine of u times u prime. Let's do some cleanup in terms of just trying to mesh everything into one fraction. So the 2 and the 1/2 x can just cancel out to be 1. The x and negative sine x squared can stay up top. And then we can push that cosine x squared to the denominator, turning into a square root. So yeah, so you can either leave it as a rational exponent or bring it, convert it to a radical. Either is fine. Okay, let's see if we can try example 4. Example 4 should feel very much like example 3. Chain rule involved. Outside's derivative first. We just go through power rule. Next up, tangent's derivative. Secant squared u times u prime. Any questions so far? Okay, number 5, we're just going to find y prime. Okay, so I want to point something out here about this problem. The number one issue that students experience on the quiz is not getting the chain rule correct. And the reason why the chain rule can be a problem on trig functions is because a lot of times you're going to see trig functions written this way, where there's a shorthand indication or a shorthand way of representing raising a trig function to a power. So if you ever see this, you always want to spend the time to rewrite it using brackets. Because the issue is, if you don't do this, tendency is you may try to go through chain rule in this form, but you're going to forget to identify the outside and inside, and something is going to get missed. Okay, so whenever you see a trig function written in this form, spend the time, write it with a set of brackets. Visually, it's going to be a lot more helpful for you because you're going to clearly see what the outside portion, what the inside portion, and then you're going to go through your chain rule like before. All right, I think typically we don't have any trouble with radicals because I think we're just used to converting radicals to brackets, but sometimes we feel like, oh, this is fine. We can just go directly into chain rule, but it's still easy to miss the whole chain rule process without visually seeing that set of brackets. So yeah, spend the time to do that because if you don't, I see 80% of the students make a mistake because they miss something, not having that visual reminder of that bracket separating the outside and inside portion. Okay, so now we know this chain rule involved. So we take care of bracket squared. So go through power rule here, outside portion. Now we took care of outside derivative, keeping inside intact. Now we can move into the inside derivative. We know secant u's derivative is secant u tangent u times u prime. So secant u tangent u times u prime. What's u prime going to be? It's pi x's derivative. Just pi, yep. Okay, so for cleanup, I'm just going to pull the coefficients in front. You don't have to, but I'm going to just merge the two secants together here. All right, example 6, sine of x plus y equals 3x plus 2y. What process do we have to make sure we go through here? Anything different about how this is set up compared to previous problems? Anything you notice about the variables? Yeah, so we got to go through our process here. This is what this is called here. multiple y variables, so implicit, yep. So we have to keep track of our dy dx's, right? We have two y variables. We're going to be expecting two dy dx's to pop up. Careful how we handle this sign of x plus y. X plus y is inside the sine function. We can't distribute and call this sign of x plus sine of y. Okay, so we have to leave that x plus y alone. We can't distribute that sign through. So we'll go directly into our derivative rule. We know sine's derivative is cosine of u times u prime. So we'll just follow that rule. Cosine of u times u prime. What's x plus y's derivative? X becomes 1, y becomes dy dx. Okay. Okay, 3x becomes 3. 2y becomes 2 dy dx. All right, we have to do some cleanup here. We're trying to eventually isolate our dy dx together. Now, this cosine of x plus y is one thing, right? But the x plus y is outside of it. So we can do this. We can take this x plus y, sorry, cosine x plus y, and distribute it through. And the reason why we want to do that is we want to be able to kind of free up that dy dx term so we can start moving things around. But right now, it's kind of stuck inside this expression. So we'll distribute that cosine of x plus y through. And now we can have 4 individual terms that we can move around freely and group them the way we want to group them. Is everybody good with moving from this step to this step? So now I'm going to collect my dy dx terms on the same side. Then I can factor it out and I can just isolate my dy dx. So I just combined 2 steps in one. I put them together on the same side, subtracted the 2 dy dx, and then I factored the dy dx out. And then I can move that cosine of x plus y to the right side. And we divide parentheses over to the right side. Can I cancel the cosine x plus y's out and just make it 3 over -2? No. All right. So if these were all multiplied, if it was 3 times cosine of x plus y and 2 times cosine x plus y, you're free to do that. But remember, we cannot cancel the cross addition or subtraction, so we have to kind of leave this alone. Any questions? Okay, page 13. Okay, number 1, cosine q pi x squared. Find dy dx, find the derivative. Look at how this is set up. What should be the first thing that we do here? Brackets, yeah. Get that cube to be in a more visually helpful place. If you don't put that cube outside a set of brackets, you're running the risk of not seeing the full picture, and the chances of making a mistake with forgetting something within chain rule is gonna be higher. if you don't take that visual step. Again, it's not required. If you get the answer correct without doing it, that's perfectly fine, but I'm just letting you know what patterns I've seen over the years. Yeah, it makes a big difference seeing that that bracket outside. Okay, so now identify your outside inside, go through your chain rule. And now that we've taken care of outside derivative, we're move on to cosine of u. Cosine of u's derivative is negative sine of u times u prime. Okay, what's pi x squared's derivative? Pi x. Okay, as far as cleanup goes, let's just push all the non-trig stuff in front. So the negative, the 2 pi x, the 3. Okay, number 2, what's required? We do have to make sure we go through question rule, okay? And then after we find the derivative, then it's asking us for us to find the slope. So after finding the derivative, we're going to replace all the x values with 0 and try to get it down to a numeric answer. Again, this is non-calculator. We have to rely on our unit circle knowledge to get to our final answer. But first things first, let's go through quotient rule. Okay. Sine the pi x derivative, sine of u becomes cosine of u times u prime. G stays. F stays. G prime, cosine's derivative is negative sine of u times u prime. All over denominator squared. Okay, let's not worry about cleaning up. Let's go ahead and just replace all the x values with 0, and that should wipe out a lot of the terms. We'll see. So the nice thing about sine of 0 is 0. So anything connected to sine of 0 is just going to disappear. Cosine of 0 is what? 1. Yeah, so pi times 1 is still pi. Pi over 1 squared. It's just gonna just be pi. Okay, number 3. Okay, number 3, what process do you see to find the derivative? What's involved? Okay, numerator, denominator. Got quotient, right? What else? Implicit, yeah. You see y is not, it's not y equals, right? This is y is kind of mixed into the equation here, so we know we got to keep track of our, there's 1 dy dx that's going to pop up along the way. Okay, so we'll do quotient rule on the left side here. Okay, 3 cosine of y becomes -3 sine of y, right? Cosine becomes negative sine. And we're asking for y's derivative, so we're going to attach the dy dx. All over denominator squared. Equals 2x becomes 2. Okay, so that dy dx is kind of stuck inside the equation here. I'm going to try to algebraically move some things around so that I can eventually get that dy dx to add and subtract in a way where I can isolate it. But whenever I see a fraction equaling a value, I can always force cross multiply to occur. If I can cross multiply, at least I can get my denominators out of the way, and then I can begin to add and subtract. That can help me isolate that dy dx. All right, so I'll multiply, cross multiply here. Oops, sorry, it's 1 here, 2. Okay, cross product here. As I do that, I'm just trying to do some cleanup along the way here. and just moving the coefficient in front, making this 3 cosine x 3 cosine x cosine y. 2 negatives makes positive. I'll make this 3 sine x sine y dy dx. And then I'm also squaring everything inside here. 3 squared is 9, and then making it cosine squared. Right, so now we have 3 terms. We can just move them around, get that dy dx term by itself, and then divide that term over to the right side. Okay. Number 5. We'll skip number 4. 4 is a little bit strange. Yeah, we'll do something more similar to that later on. But let's skip number 4 and go to number 5. Number 5 is particle motion. Now, the only thing you got to worry about particle motion, at least for the quiz, is just know how to get from position to velocity to acceleration, which just means find the derivative twice. All right. So for 5, well, in this case, we start with velocity. So we should have to go from velocity to acceleration, which is only one derivative down. And then we're going to be asked to evaluate using unit circle values. So here's number 5. So acceleration is one derivative down. But to get to acceleration, what's involved here besides sine and tangent's derivative? Product rule, yeah. You see 2 distinct functions being multiplied together, so we got to go through product rule. Sine of u becomes cosine of u times u prime. Tangent's derivative is secant squared u times u prime. And now find the acceleration at t equals pi. So now we'll replace every t with pi and use our unit circle values to get it down to numeric representation. Okay. On the quiz, on the AP exam, you cannot leave your answer in this form. You have to evaluate your trig. All right, so cosine of 2 pi is same thing as cosine of 0, which is 1. Tangent of pi is going to be 0, right? We know that pi's ordered pair is -1, 0. Tangent is sine over cosine, y over x, so 0 over -1 is going to be 0. Sine of 2 pi, that's going to be 0. And the secant squared of pi, if you're unfamiliar with secant, you can always convert it into something that feels more familiar, which is cosine, right? You can always flip cosecant and secant into sine and cosine squared, cosine of pi feels more familiar. Cosine of pi is -1. -1 squared is going to be 1, so that's just 1 over 1 is still going to be 1. But everything's going to end up zeroing out here because that tangent is going to force a 0 here, and the sine of 2 pi will force a 0 here. So a of pi is just going to be 0. Okay, last one, number 6. Find the equation of the tangent line. So we need to find order pair, find the derivative, find the slope, point slope form. Okay, we're going to find order pair first, and then we'll find the derivative. But what should we do with this function? That'll be a useful step. Brackets, yeah. The set of brackets show up. Again, it's not required if you don't do it, but you do run a high risk of misinterpreting some things if we don't take the time to rewrite that shorthand form into a more visually helpful form. Let's find order pair first. We can just plug pi over 4 in for x. We know we're going to need that. What's tangent of pi over 4? 1, yep. 1 cubed is 1. 1 times 2 is 2. Make sure we don't do this, right? That we don't do 2 times 1 and then cube it. So that cubing is only going to impact the 1. Okay, so my order pair is just pi over 4, comma 2. All right, moving on to our derivative, which will help us get to our slope. To get to our derivative, having that bracket is a good visual reminder that there's chain rule involved. Okay. Outside derivative, 2 bracket cube becomes 6 bracket squared. Tangent's derivative, inside's derivative becomes secant squared. Now that we have our derivative, replace every x with pi over 4. Tangent of pi over 4, again, we know is 1. That's nice. Secant squared of pi over 4, I will rewrite it as 1 over cosine pi over 4, and then square that. Again, anytime you see a shorthand, it's just easier to have it outside a set of parentheses or bracket, so you're making sure that you're evaluating correctly. Cosine of pi over 4 is root 2 over 2. Root 2 over 2 squared. So this ends up being 2/4 or 1/2. And if I flip 1/2, I get 2. So my slope is just going to be 12. All right, we have everything that we need. Our order pair. Pi/4, comma 2. Our slope. M is 12. And now point slope form. Okay, so we got through our first quiz review, which is going to do reviews every day leading up to next Tuesday's quiz. Okay, your homework, I'm not going to give you any homework. We just had classwork, so I'm just going to be checking page 13 tomorrow, walking around, giving you class credit for that. All right, come get your phones.
Is this like each micro? Yeah. You have reading check, is it?